because, well, I graded all of them, and then I realized I graded all of them wrong. And so I was like, well, crap, I'm an idiot. Um, okay, so let's take, this was the snippet that I actually, that was dang it, the actual problem. Let me make two modifications of this. Okay, so the top one was the one that was actually on the exam, and I want to talk about sort of two variations of it. So let's take just this piece here. Okay, so let me actually make that a fourth version, and I'm going to put it at the top actually. Okay, so what was the assumption here? The assumption was that do stuff was O of n, right? Okay, so if you have an O of n thing inside a loop that's going to go on the order of n times, right? So if this had been like n minus 5 or something, what is this, the part that's highlighted? If you do an O of n thing, basically n times, then the total is what? N squared, okay? Um, okay, so does that make sense? If you do an O of n thing n times, or roughly n times, then what do? You multiply. Okay, is that all right? All right, now let's go down to the one here at the very bottom. So the snippet, or sorry, do stuff, what did we say was O of n, right? What happens if we do an O of n thing, and then we do an O of n thing? What do you think the result is? What's the trap answer here? O of n squared is the trap answer, okay? Now let's think about why this is O of n and not O of n squared, okay? What does it mean for do stuff? All right, what does it mean for do stuff to be O of n? It means that do stuff, the runtime of it, is less than or equal to some constant times n, okay, for large values of n. Okay, so what's the runtime if I do stuff twice? So the snippet would just be less than or equal to twice that, right? Because snippet, I mean, if I run do stuff twice, then it obviously takes twice as long. Yeah? Okay. Well, so that means that snippet's runtime is less than or equal to 2 times a constant times n. Well, what's 2 times some constant? Just some other constant, right? So we have that snippet is less than or equal to a constant times n, and therefore, what does that mean that snippet 3 is? If it's less than or equal to a constant times n, then that thing is O of n. Am I speaking Greek this morning? Is it just because it's Monday of Bell Week? Yeah. All right. Well, anyway. Okay. Now, if we go up to this one, snippet 1, which was actually on the exam, okay, this part of it, the part that's highlighted by what we said above, is O of n squared. Do you guys buy that? Because we do an O of n thing inside a loop that's got basically n times. Okay, so this is O of n squared. Well, what does it mean for something to be of order n squared? Okay, so the one of the loops there we said was n squared. Well, if the first loop is n squared and the second loop is n squared and they're not nested, they're sequential, the total is still n squared. Okay, why? What's basically twice n squared? Is that still an n squared thing? Yeah, it is, right? Because, like, if you're less than or equal to twice a constant times n squared, well, what's twice a constant? Some other constant. All right, so now you're less than or equal to a constant times n squared. Well, that's the definition of being O n squared, right? Okay, so you might say that this is O of 2n squared, but the constants don't really matter, so we just ignore those, okay? All right, so this guy was O of n squared. Now, what was maybe the trap answer that I was actually expecting you guys to get here? Well, that would be the case of snippet number 2 here. What's this guy? Okay, so what's the difference between snippet 1 and snippet 2 just in terms of the structure? Okay, forget about the O of whatever, right? Yeah, snippet 2 is nested, whereas snippet 1 is sequential. Okay, how do you tell just reading it? Yeah, the indentation, right? That's the beauty of Python, is that it's all handled with indentation. Okay. Okay, so if this one is O n squared, what's this one? Well, we do an O of n thing inside a loop n times, inside another loop n times, and they're nested, so it's going to be n times n times n, and so the total is O of n cubed. Okay, so you guys got that? Does that make sense? All right, so now, the last thing, and a few of you guys realize this, if something is O of n, is it also O of n squared? Yes. Does it go the other direction? No. Okay. All right, so, but is it helpful to say that something is O of n to the 30,000 if it's also O of n? Right, what's more useful information? Knowing that something's O of n, right, if it is. Okay, so when we do these, we want to say the minimum thing that we possibly can, right? So if it's O of n squared, but not O of n, that's useful information. The fact that O of n squared is also O of n cubed, well, yeah, okay, great. But we can do better than that. All right, does that make sense? Okay, so I gave everybody the point for this because I graded all of them and then I realized I was an idiot. Basically, I graded them thinking that I had written the problem as snippet 3. And then I realized that I hadn't. It was actually snippet 1. So I was smoking something yesterday. I blame the time change. How about that? Do you guys like the time change? This half of the year I like it. Yeah, because you got to class and the sun was actually up. Um, yeah. What about in April or whenever we flip the other way? I hate it. So I wish we would just stay on it all year or do it none of the year. Like just pick one. I don't care. Just pick one and stick with it. Anyway. All right. So there was that. Okay. So other thing we want to talk about is Minecraft. So if you have not already downloaded the education version onto your gadget, please do so. Um, so we're going to work through basically to build up to a project. There's a whole crap ton of activities and lesson plans and things that Microsoft has available here. Um, some of them are wildly not appropriate for for you guys. They're for elementary school kids, and they have nothing to do with computing. But there is a set that does, okay, and it's called Coding with Minecraft. And there are 10 lessons built into it. The first one is really, really short and stupid, but I wanted to show you that one uh, simply because this is how you'll do really all of them, okay? So if I go to Unit 1 Introduction, okay, there's a couple things that I want to do, okay? So if you hit download world, okay, what that's going to download is this file here, and it's something.mc world, okay? And then I need to run Minecraft, obviously. And so let's get that going. Okay, so once you get into the game, then just hit play. And then you're going to come down here to where it says import. And it's going to fire up a thing. And then I'm just going to import that world. Okay. And then if I go to view my world, it's now there in my list of worlds. Okay. So in this case, I've made a second copy of something. So if you import something twice, you'll have two copies of it rather than it nuking it. Okay. All right. So if I open that and hit play, then, okay, it'll pop us into the game, right? And the one thing, if Cody were here, maybe he's online, he would see this 45 to 60 minutes and say, oh, but there's 10 of these things? This is going to take forever. Okay, these things will not take the time that it states here, okay, for a couple of reasons. These time estimates are designed for middle school children, okay, and the lesson plans that go with these things have a bunch of worksheets where you're like, where might you use repeating a procedure in real life? Write down your thoughts. Okay, we're going to skip all that crap. Okay, so this will not take you as long as it says it will. Okay, if I right click on the teacher, then the teacher, well, what? The introduction world. Yeah, coding with Minecraft, and then, actually, you know what? Let me put the link to that on Canvas. That might make things easier. Um, okay, I just put a link on Canvas. Okay. All right, so now if you click here, student workbook, it will download, and this is the stuff that we're going to sort of ignore, right? It'll download this thing that basically has all of the instructions for what we're going to do, okay, or what you're going to do. But then there's a bunch of stuff like this. Why is computer science important? How does it help us? Write your ideas here. Okay, obviously now we're not going to do that stuff, right? So these lesson plans are sort of designed with the idea that you'd print them out, give them to a classroom full of students, right, and off you go. But some of it is, not really age appropriate to you guys. Um, okay, so anyway, all right, but what we're going to do is basically this one shows us how do we get into the game, what are the controls for the game, um, and how do you get into the code builder and that sort of thing, okay? So um, for some of the other ones, this might be sort of useful. All right, but if I hit C for code, right, then the tutorial, it says, new start here is chicken rain. And that's exactly the one that we want for this guy. Okay, so let me blow the code builder up. Okay, so this basically is in tutorial mode where it has some instructions up at the top, and then it basically just says, hey, do this, do this, do this. All right, so put in an on-chat command. We've already got one ready to go. It's on-chat commands run. And so I'm going to change this to chicken. Okay, great. Put a spawn. We'll spawn an animal of type chicken. So there's all these other animals, obviously, but we'll just do the chicken. Okay, at 000. Okay, now this is one thing that's kind of nice about the coordinate system in Minecraft. So if you're in the world, right, every point has some XYZ coordinate, right? And if your world's really big, then maybe those go up into the thousands or whatever. And it's, each coordinate is basically a block unit in the game. But you see the little tildes that are to the left of the zeros in this case? The tildes say that this coordinate is defined relative to the player, okay? So tilde 000 is actually wherever the player is in the game. If I move, my coordinates in the entire world have changed, sure, but relative to me, 000 is exactly where I'm at, okay? So if I wanted to spawn something at the player, I would do this, right? I would use the relative coordinates rather than um, the absolute coordinates. Okay, now, if I were to run this right now, it would basically spawn a chicken inside me, okay, which is clearly not what I want, okay? Um, and so I'm going to change one of the coordinates, okay, and this is mildly annoying the way they do the coordinate systems, is the y coordinate is up and down in the world, okay, rather than I would have made it the z coordinate, but whatever, that's just the way they did it. Okay, so this would be 10 units above me, okay, instead of exactly in it. Okay, all right, now if I hit the run button, okay, here, well, if it, okay, I don't know why it did that. All right, let me hit exit tutorial. Oops. Okay. So if I hit the run button, basically it'll activate that in the game. Okay. And then if I hit T for chat and type chicken and look up, well, it just spawned a chicken who is now fluttering gently to the ground because gravity. Yay. Okay. How exciting. Yeah. Okay. So what can we do to make this more fun? Huh? Huh? More chickens. Let's just spawn a crap ton of chickens. Well, could I duplicate this? Yeah, well, if I only want 2 chickens, then maybe that's fine. But if I want 100 chickens. What do I want to do? Yeah, I want to repeat, which is a for loop, right? 100 times. Okay, now the chickens haven't spawned yet because why not? Yeah, I've got to type the chicken command again. And there we go. There's 100 chickens all gobbling about or clucking about, whatever. Okay. Now, why did they kind of spread and fan out a little bit? Because if you try and spawn them on top of each other, they kind of bounce a little bit, and so that's why they kind of flew in lots of different directions. But I was technically spawning them all at the exact same location. Okay, and now we've got a bunch of chickens. Great. Okay. All right, so does this kind of make sense? All right, so that's literally it for the first one, right? Is just the whole point of this is how do you import the world, okay, and then access the code builder, okay? So the all right, questions on that? Pretty straightforward. Yeah. Oh, yeah. So the tilde indicates that it's relative to the player's location, okay? And the coordinate system is that up and down, like going towards the sky and towards the ground, is the y-axis. Okay, so it's the second coordinate, not the third. That's mildly annoying because that's not the way we do it in math, but well, sort of. But it actually does kind of make some sense. So actually, let me sketch this on the board. If you go back way back in the day in computing, okay, and you've got a screen, right? Well, you got to put the origin 0, 0 somewhere. So where would be a logical place to put it? In the middle would be a logical place. What else would be a possible logical choice? Okay, the downside to putting it in the middle is that not every screen has the same size. Okay, so and of course you guys know this, right? You know, what's the difference between if 720p and 1080p, you know, monitor or something? It's just the number of pixels. So the convention that was used is to put the origin at the top left. Okay, and the x coordinate ran to the right. Well, that makes sense. That's just like it is in math class. All right, here's the thing that drives me nuts. They made the y coordinate run vertically. Okay, that part's okay. But they made it run down. So positive y means going down rather than going up. Okay. So is it weird in the sense that it doesn't match math class? Yeah. Is it make sense in a way though that if you're making a computer that basically can only output text, okay, right? Keep in mind that this is like from the 70s, right? Kind of tech. Then going down a line makes sense to increase the number of lines. And you kind of have to remember that screens, in a sense, back in the day, well, how many of you guys have used a typewriter before? I know, right? Or played with a typewriter that like your grandmother had that you just sat there and mashed buttons and felt cool. Yeah. But you guys know that typewriters were a thing? You know, I have to ask because I'm sure that by the time I'm getting ready to retire, I'm going to be like, so you guys remember typewriters? And everybody will be like, we saw those things in museums. I'll be like, get off my lawn. You know, kids these days. All right, so anyway, that was the coordinate system used. And then when 3D coordinates became a thing, well, we already have the x and y defined. So what did they define z to be? Either going into or out of the screen. Okay, because, well, we can't redefine x and y, so we'll do that. Now, what makes this annoying to me is in math class, what's sort of the handedness of your coordinate system? The normal math class coordinates. Or how many of you guys have taken any physics? You use the right-hand rule a lot, right? For like cross products and torque and you know, Coulomb's law and stuff like that? No? Okay, this is a left-handed coordinate system. Okay, now, is anybody in the room left-handed besides Owen? I'll tolerate his presence because he helps me out. But if you're left-handed, you're an evil, horrible person and should go away immediately. No? I'm kidding, of course. I don't care what hand you use. But do you guys know what the Latin word for left is? No? Anybody? Sinister. Guess what word we get from that? Sinister. Yes, because left-handed people are evil. Evil. You know, we joke, but, you know, back in the day, like even not 100 years ago, if you were a left-handed child, they'd like punish you and make you use your right hand. Hmm? Yeah. So, yeah. Anyway. Okay. So the tilde then remember is it's relative to the player. Okay. And so positive y in this case goes up in the game world, and negative y obviously would go down. So if I spawned a bunch of chickens at -10 there, they'd be spawning basically inside the ground. But it would be whatever that's 10 coordinates below me. Okay. Now, obviously, I don't want to spawn chickens in the ground. I could, but whatever. Okay. All right. So that's literally it for this first thing. And when you finish a tutorial, okay, it'll plop you back into full-blown code thing. All right, so the tutorials are designed in such a way that they're not going to give you all of the blocks. They're only going to give you the ones that are actually necessary to do whatever it is you're trying to do. Okay, but in sort of when you have access to everything, which is the same as just starting a blank project, right? You've got all of this stuff, okay? And the whole point of all of these tutorials is basically to go through and teach you all of the necessary pieces. You know, how do you do loops? Well, we kind of already saw one, right? Repeating something 50 times or whatever, that's pretty obvious how that ought to work. But there's some stuff that isn't necessarily obvious. For example, the variables or the agent or how you do functions and things of that sort. Okay, so and then of course there's the advanced tab that's going to get you functions, arrays, the builder, shapes, extensions. There aren't any extensions that I can find for the Minecraft thing, so obviously we won't use that. Okay, all right, so let me close that and let me quit this world. Oops, that's not what I wanted. Okay, so number 2, right? I imported it yesterday, so it's already there. Okay, and then if I go and I talk to the, read the chalkboard, it says, okay, it wants us to be at the following coordinates, and if you type a chat command /TP for teleport, and then 6769 -557, that's going to take you to some spot in the game world that that they want. Okay, and so this one's kind of maybe not all that particularly exciting in terms of computing. Okay, but it wants you to basically build, you know, connect things with blocks. So it's sort of a tutorial as to how to do that. Okay, and if I go to the teacher, right, blah, 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 and if we hit tutorial, okay, that'll load the code builder with the instructions and for what to do, okay, and basically what it's going to teach you how to do is not just to place the things in the game world, but how to make a command do it instead of you just manually placing stuff in. Okay. All right. So do you guys kind of get the idea behind like what we're going to do with all these things? Okay. So sort of the layout for the next, you know, well, basically the rest of the semester. We've got sort of three major things to do. Obviously the Minecraft stuff. Okay, so you guys are going to work through these tutorials, and like I said, they will not take the time that it says it will take. You guys will be a lot faster, and that's going to culminate in a project where you guys will, basically make something cool. Okay, well, make four cool things, but you'll make some cool stuff um, with this. Okay, the other thing that we need to do is we're going to sort of, in a sense, kind of go full circle back to the very beginning of the semester. So at the very, very, very beginning, all right, after we took apart the computers and stuff, what did we look at then? We looked at single individual transistors, learned how they worked, and then said, okay, what happens if I start putting multiple of these things together, okay, to form logic gates, okay, and gates, or gates, and so on. Okay, so if I took, so what we did when we went from a pair of transistors to then drawing a logic gate, we went one layer of abstraction. Okay, we were no longer worrying about the individual transistors, but sort of how they function collectively as a gate. Okay, and we had a gate. Okay, great. Well, what happens if we start putting together lots of gates? Well, we did that a little bit to make some circuits, and the circuits were just kind of made up for they didn't necessarily do any particular function that was important to us. Okay, so what about if we abstract sort of one layer up and start to group gates together to actually do computery type things? So for example, how would I design a circuit with gates that would actually do addition for me? Right, so if I gave it, if I gave you guys two 8-bit numbers and I say add them, well, how do you add numbers, right? You do it place at a time, and there's some carrying and borrowing and blah, 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 right? You guys know how to do arithmetic. How would I build a circuit to do that? Yeah? Okay. And then if I built a circuit to do that, so now I've got an addition module, I need some memory, sort of build it up there, then how do we actually program some simple machine like this? Okay, now how do we program in Minecraft? Well, it's all these blocks, right? But what really is that when all's said and done? Okay, so when I type, example code in these blocks or in Python or whatever, right? That's what you see, but is that what the computer's actually executing? Because what's code look like to a computer? What's everything to a computer? Just a bunch of numbers, right? A crap ton of ones and zeros in some sort of logical order and arrangement. Okay, so that's the level that we're going to look at machine execution. Okay, and we're going to do it on a processor that doesn't actually exist. Okay, that would be, if it did exist, it would be sort of late 60s, early 70s kind of technology, okay, in terms of the architecture. So we'll look at basically how to program and what this sort of simple computer looks like, although as you guys are going to find out, it's not so simple as you might think. And then you guys will have a programming project or, series of programming assignments on that thing. And then, of course, the very, very last thing, what do we get to do in this class? Yay, hooray, in December. Yeah, final. It'll be so much fun, right? Yeah? And we kind of drew the short straw on when our final exam time is. But you know what? It is what it is. The registrar giveth, the registrar taketh away. Okay? Um, so, yeah. It could be worse, right? We could have had Friday afternoon, but we got Friday morning. Or we could have even had Saturday. Huh? It is a thing. And I have used the Saturday final once. My students were not happy. Even when I brought donuts, they were still not happy. So anyway, okay, so that's about it that I wanted to talk about today. So I guess we got some time to burn. So if you guys want to just work through the Minecraft stuff and you sort of import world by world, and you guys are going to kind of burn through the first few of these because they're pretty quick to college student age, right? So, question, preguntas, fragen? No? Oh, oh, this one or all 9 of them? No, no, that would maybe be a little ridiculous, even if it's, well, actually, that's a great idea. Do you think that's totally reasonable to get through all 9 of them by Wednesday? Yeah, it actually would be. No. Yeah, get through as many as you can, obviously. But Wednesday, actually, we're going to start talking about the machine stuff, the architecture and gates and things like that, because this stuff you can do on your own. It's not rocket science. Um, and yeah, so Wednesday we'll start with something completely different. Yeah. The other thing was my note yesterday clear about the core skills exam that you guys all did fantastic on. Okay. And everybody had to change the sheets in their bed and maybe put a plastic cover over the mattress like you were a 6-year-old again, uh, or whatever. Yeah. Some of you guys really screwed the pooch on that one. Okay. But guess what? You do, right? Okay, that's one reason you guys may have noticed that I didn't give you any partial credit on this because you either know this crap or you don't. Um, so yeah. Anyway, yeah. So the instructions basically are come to my office sometime on Friday. Okay. All right. So any other questions? We'll kill the stream. All right. Well, goodbye, internet, and see you guys Wednesday.